I'm Anthony Ison. I'm a Senior Software Architect with SSW. I'm here today with Aaron Powell, a CDA from Microsoft. We're going to talk about durable functions. Thank you for joining us, Aaron.
Howdy everyone, thanks for having me.
Durable functions are part of the Azure Functions provided from Azure?
Yeah, so durable functions was something that we released, I think about 18 months ago. The initial version came out as an extension on top of Azure Functions. So Azure Functions is our serverless product. It's one of a couple of serverless options, but it's the code first one. So if you're a developer at heart like myself, you probably prefer to write things in code and express things that way. And Functions is the way that you can do that with serverless. So with Azure Functions, we can build an event-based workflow. It could be listening to a HTTP endpoint. It could be doing a trigger from some other event like a queue or a service bus or a Cosmos DB, a bunch of other stuff that could be happening with inside of your application and execute some processing.
Fantastic. So if I've got a web application right now, is that something that I can actually use with Azure Functions and deploy into that? Or is it something that requires a totally different architecture, for example?
No, it doesn't really require a different architecture if you're just going to add some serverless to an existing application. Now, if you wanted to go a full serverless application and not have any traditional REST-based APIs and stuff like that, it will require something different. But serverless can be used to extend an existing application. Maybe that you want to do some processing in the background, batch processing off something that's been uploaded to your application or processing data that's coming in from a data stream in near real time. You can do that with a serverless application instead, rather than doing it in process of the web app.
Okay, so you can run these things side by side.
Yep, for sure. And with durable functions then, it's just an extension on top of that. So you install a NuGet package if you're doing .NET or an NPM module if you're doing it in JavaScript and Node.js. So those are two options that we support at the moment.
Fantastic. So if I get this correctly, it's basically allowing that individual function to not just do one thing, but to extend over a period of time.
Yeah, probably the best way they can do this, explain the sorts of things you might be doing with a durable function is, I'll bring up a slide here in our deck. Let's say that you were wanting to process some data that's come in from like an IoT device or some other external system, and you need it for one shape initially, but there's other things you want to do with that data. So what we would kind of do today with serverless processing or kind of any sort of application design is that we would read that initial bit of data, pop it in some kind of a queue, something else would read that queue, it would do its processing, it would pop it in a queue, so on and so forth. But this requires a lot of work on your part because you've got to manage that queue and you don't really have observations of, well, have I completed the full run? Am I done with that bit of data and I can delete its initial raw form because we've processed it end to end? That's the sort of thing that we can do with a durable function.
Okay, so a durable function sounds like it's going to hold all of that state and follow through the workflow, and you'll see where it's been up to, and you're not pushing it back into the service bus. Is that correct?
Basically, yeah. So it allows you to not have to think about state in what is inherently a stateless design. Serverless and I guess any sort of web programming, we tend to think about it as stateless. But if you do need to do something, you want to persist that across a couple of runs or across a couple of ways that you're looking at that piece of data, this can happen with a serverless function using the durable functions extensions.
So I understand you've got a couple of demos here for us. Do you want to walk us through that first one just to see what that actually looks like?
So let's jump over to a really simple example that I've got here of how you can define a workflow. So this workflow we'll have, it's going to serve over HTTP as an event that can be triggered by our serverless application, and it allows us to start a workflow, inspect what that workflow's current state is, and then stop that workflow. Not simulating anything overly complex, but at least showing you how a workflow is running and what you can kind of do with it.
Fantastic. So looking at what you've got here, I see F# is showing up. Now I'm a C# guy, but I can see that I can read what the code is doing at least. It's looking similar enough that I can actually look through this code and follow along.
Yeah, so if you've not worked with F# before, obviously this is a bit of a foreign construct with some of it, but hopefully it will be familiar enough. And I'm personally very much a fan of F#, which is why I've written this demo in F#, but you could do this in any .NET CLR language. So you could do it in C#, you could do it in VB.NET as well. So let's start at this first bit here that starts at line 20 in our application. If you've ever seen an Azure function before, we create a static method inside of a static class, and that's the thing that we're going to interact with. And we decorate with that with an attribute. an attribute is named function name, and then we give that the name of a function that is known to the Azure Functions runtime. The first thing that we then do with that is define some arguments that will go into that function, and these are what we call bindings. A binding is an event that could be triggered or something else that we want to inject into our function when it's run. So the binding I've got initially here is a HTTP trigger. This is because it's called a trigger event. This is the thing that will start our function. It's HTTP, so it needs some access on it. So it's anonymous access in this case, but you can put security on it if is preferred. And you probably want that in production as well anyway.
Sounds like a good idea.
The kind of HTTP verbs we're listening to, get, update, delete, etc. And a route that we're going to listen on. So this is going to be on start / and then if you've done MVC routing, that's probably looking fairly familiar as well.
Yeah.
Pulling out a token there. Yep. And then we have some inputs that go into that, which is the durable orchestration client. This is the thing that manages our durable function, allows us to engage with the durable function behind the scenes. Because what we've initially got here in the start workflow function is just a standard Azure function. We then start a workflow in the background with our orchestration client. And then I have some other inputs that come into this function. Really, the most interesting thing that this function is doing down here is on line 29, where it's using the orchestration client to start a new function, a new durable function in the background. So we're using an event. So event name is a variable that I've got defined in my application, which is just the name of the durable function that I want to initiate. If you're doing this in C#, you could use the name of operator to reference a class. And we'll have a look at what that's actually looking like behind the scenes in a minute, and hand over the state that this durable function is going to then work with. I have a couple other functions we've got defined here. We'll have a look at those once we get the demo up and running. First off, let's just start it up and see what it looks like.
Sounds good.
Now the Azure Functions has started running. I'm just running this locally with the local Azure Functions tools. I'm also running this in VS Code, but you could be doing this in full Visual Studio if you prefer. I have another demo that we'll get to, and I'll do that in full Visual Studio. But we're using some tooling that we provide just to simulate running the serverless functions on your machine rather than having to deploy everything straight to the cloud. And we'll see that we've got 3 functions that have been detected by that attribute. We've got check workflow, start workflow, and stop workflow. And the URLs that attach to them, the HTTP verbs. Now, if we had other functions that were there that are listening to other events, they'd be defined and appear differently. In fact, you can actually see one up here called workflow.run. Just highlight that. So that's actually the durable function that's running in the background, but we haven't actually triggered that yet. So I'll jump over to Postman and let's do a request at that HTTP endpoint and see what happens.
Okay.
What do we want? We want whoops / API start, and we'll start one here. So I'll hit send against that. Hopefully this will come back with a 200 error. Otherwise, I'll have to go and work out what's wrong with my code. Sorry, should come back with a 200 error. No, should come back with a 200 success, shouldn't it?
Yes.
Excellent, it did. What we've done there is we've started our durable function in the background. If we hop back to VS Code, we'll see a bunch of stuff has dropped down into the logs that's told us that that's up and running. The interesting one here is if we look at the very top of our log, we'll see that the function workflow orchestrator has been started and it's in its running state. So that's that workflow that we started on line 29 that's running in the background now and doing some processing. Maybe we should jump over and have a look at what that looks like. So this is just another style of Azure function, but this is the durable function specific component to what we're building. I see it's got a function name that I've defined, that attribute. It's defined as workflow, and you'll see the event name variable on line 7, which is what I used back on the other file. This time, the trigger is an orchestration trigger, not a HTTP trigger, because it's being triggered by our durable orchestrator. We get an orchestration context in here, so we can have a look at what's come in from our durable function. From that, I can unpack the state that was provided using this get input. I only provided a simple string into this, but I could provide a more complex object if I wanted. And that would get serialized down and then rehydrated back out inside of my durable function.
Okay, so I could pass in, for example, some data. I could serialize that into JSON and pass that in as a string instead.
Yeah, so the durable functions framework will actually take care of all the serialization for you. So you don't have to think about doing that. You just say, here's an object that I want you to give across to this other function.
Oh, that's handy.
Yep. And we'll see it's done just a log message saying the workflow has started, which if we have a look in our logs, we'll find that just here. So it's up and running. But what's it then done? Like I said, that the point of this is to simulate a workflow. Well, now on line 17 here, it's waiting for an external event. So our orchestration context, our orchestrator, our function, is waiting for something happening, something else to happen in our system to say, it's time for you to continue. Because a durable function can be used to pause execution on whether it's an external event, whether it's a timer, a variety of scenarios like that. In this case, it's just sitting there not doing anything because it's waiting. And we can actually have a look at that. If we jump back to Postman, and I'll go to one of the other endpoints, check, which I had in there, which is the check workflow, start that up. And now we have a look at the JSON payload that I've got down here. So if we see the output that we have down here this time is that we've got a couple of instances that have been, so an instance that's been run, which is called workflow. See all that information there. It's got the input that we provided it from that string. But obviously you could have a complex object that would be appearing here and some information about that. The durable function name, some metadata, when it was created, when it was last updated, and its current status. Now, this is an enum in .NET. That's why I have a 0 there because it's representing that it's in a running state, but it has completed and running of the other states that it could have. Inside of this bit of code, I've got a check to try and find out what instances are running or what workflows are running in the background that do match that input. So if we had a whole bunch of these running, I could say, well, actually I need to interact with just one in particular. So that's what that second bit of output is there. Now, obviously I only have one running, so that's why I only get one result in both of the arrays there.
Great.
Now, the final thing that we might want to do is send that event to the workflow to stop it. In a real application, this might be coming from a trigger that's happening somewhere else within inside of our system. It might be listening to another queue message, or it might be a timeout that's happened because we're waiting for an external event, someone to approve, like click a button in a web application. So when that happens, it will trigger off here.
And so I imagine you could also use a timer there to cancel that if it took too long, for example.
Exactly. And these are asynchronous operations. So in F#, the way that we do asynchronous operations is with this task wrapping it. So this is using the C# async behind the scenes. It's converting it with some F# magic. We'll go with magic for the context here.
Okay.
And the do bang is kind of like in C#, you might just do await something. We have let bang variable, which is kind of like var foo equals await an asynchronous operation in C#. But this is just an async that returns void or doesn't return a value. So we're just waiting for that. But because it's an asynchronous operation, you can combine multiple asyncs. We could start a timer and wait for an external event, and whichever one completes first results in some other execution path inside of our code base.
Okay, and so this reads fairly synchronously as well. So It's going to start, it's then going to wait for these things that can happen. And so I imagine you could have a whole bunch of things that you might need first. So this event and then this event and then this event going through different states until it's finally finished. Exactly.
You could definitely do it that way. And your orchestrator could be managing a whole bunch of essentially sub-orchestrators of other workflows that it's in turn monitoring.
Okay.
So I'm just going to pop a couple of breakpoints in here so that when we come back to Postman and hit the other endpoint of stop, so we're going to stop that running workflow.
Right.
So it did give us a return value, which is the instance that it matched based off the input that we provided to the API call. But it's immediately returned. And if we jump over to VS Code, we'll see that our workflow is still running. Because it's all asynchronous, our workflow will execute at its completion, or this event has been triggered and will be picked up at some point in the future and continue on at some point. So it's all very async in operation. It's not immediately, I said I triggered an event and that event will be done and then I can return my HTTP endpoint. So this is really for that distributed disconnected style environment.
Right, so the 200 was from your stop request.
Yep.
And then that's given off another event, but that function is now finished.
Yep. So the original function, the HTTP function, is finished, and now our workflow has gone, oh, hang on, you told me an external event. I've got to do something with that. So now my breakpoint has been hit, and that can run through to completion, and then that workflow if I get past all of the breakpoints that I've got set, that workflow will stop, and then it's completely turned off behind the scenes.
Fantastic. Okay, so we've demonstrated there that we've set up a workflow.
Yep.
And we've got 2 HTTP triggers, so we can start and stop. We've shown that workflow actually stopped in the middle, and we could build quite a complex workflow in all of that.
Yep.
So I've also heard about this Durable Functions v2.
Yeah, so that's something that is just gone into beta 3. It's been an extension on top of an extension, I guess. But one of the really exciting things about Durable Functions version 2 is a new style of functions, which is called durable entities. So where Durable Functions, as it currently stands, requires us to do a lot of sort of coding particularly to manage complex state. That demo that we had there was only fairly simple. The state that we're passing back and forth was just a string. But we had something more complex. It becomes a little bit more cumbersome to manage. So durable entities helps us take care of that. And I've got a good demo that can illustrate how that works. So what I've got here is an application that one of my colleagues has created called Durable Dungeons. It's a text-based adventure game using the Durable Entities framework to manage the state of the game. So as you play through the game, you fight baddies, you pick up treasure, you pick up weapons, all that sort of stuff. It's all managed here. And what I've got on screen there is a durable entity. But if you looked at that, you'd probably just tell me that's a plain old C# class, isn't it?
It does look like it, yeah.
Yeah, we've got a couple of properties on there, and that's the game state, or the state for this particular entity. So a user has a name, whether they're alive or not, and what room they're currently in. We also have a couple of functions such as kill, set room, add to inventory. And then right down the bottom here, we have our function name attribute on a function. And this is what turns it from a standard C# class into a durable entity. So this function here, this is an entry point that the Durable Entities framework will be able to engage with. And we have our trigger type again, so an attribute of entity trigger that has an I durable entity context, which is similar to the orchestrated context that we saw in the last demo, but this allows us to dispatch actions against the current entity. And the way that we would use that, jump over to a different class here, is if we were to say, want to create, let's use the monster instead this time. We'll jump through to this create monster method. So this is another durable function that's being executed. So these are functions executing functions, building up a workflow. And here we're creating a new monster. So he's just got a little thing that builds up that new Poco. We are creating an ID for that monster based off of the class and some other information, such as the user that's in the game at the moment. So use the username and the monster to create a unique ID so that we can do that association, kind of like a database, but we're never writing to the database. It's all being tracked by our entity store. We're then going to signal against that entity. So this is similar to when we started a new workflow, or we wanted to execute an activity against a running workflow. We might want to signal at an entity some operation to do. So in this case, it's just creating a new monster and providing some information to that monster. And then this is going to log out to the console and eventually complete. But what this has done behind the scenes is that monster is being created. It's then getting serialized and stored because it's got some game state against it, or it's got some application state if this wasn't a game. And we've never created a connection string to a database. If you look at the inputs to this durable function, there are no inputs that would indicate that it's writing to a database. There is a queue that's being used, but that's just a message back and forth between the UI and what's happening here. Everything is just state managed on our behalf. We don't have to do anything ourselves.
So where does this monster actually exist? It's in memory, I'm assuming.
So we keep it both in memory and it's persisted to table storage is the default store, but in Durable Functions version 2, the storage is actually pluggable. So if you didn't want to use table store, or table store was too slow for what you were wanting to use, you might want to use a Redis cache. Or maybe you had some data that is better represented in a relational structure rather than a unrelational structure. So you could write a SQL plugin for it. So you could write to a SQL database. But you don't have to think about that from your application. You just say, here's my entity. Hey, framework, you work out how to store that. And then you connect, when you create your functions, you say, here's the storage models that you're going to be using.
Fantastic. So it sounds like it's going to keep it very decoupled. Your application doesn't necessarily need to know where this is being stored. It's just coming from the context of the of the Azure Functions itself.
Precisely, yeah. It helps you focus on what your application has to do, the logic that it's got behind it, how it will work with data, without overly concerning yourself with, ooh, am I writing this to a SQL server, or am I writing this to table storage, writing it to like a NoSQL database, or whatever it might be. You know, it's data. You work out how to store it, just the same as you're working out how to do the communication between each of the durable functions.
Great. And so I'm guessing that once we've got this entity, we can call other things against it. For example, if we wanted to kill off the monster or do damage, or I'm not sure what else you're tracking there, but that would then be saved as well. So as we make changes, it would then go back to wherever it's come from and made available for other functions to call.
Yeah, so this monster has a bunch of state against it, so whether it's alive, what inventory it has against it. And the same way that we're using signal entity against the operation of new, we could signal any other entity function that it has, like kill and who's killing it, and all that kind of stuff.
Great. So if I wanted to learn a bit more, it looks like it's worth looking at. If I wanted to find out more about it, where would I look?
So there's a couple of links that I've got here that I think are most useful for you to have a look at next. So we've got the Durable Functions v2 short link. So this takes you through to the documentation on the Azure Docs website that will talk to you about scenarios that you might be using durable functions and durable entities in. Has a bunch of examples of how you could use those and that kind of stuff. The first GitHub repo there is Jeremy's Durable Dungeons application that we saw there. Yes. It has both a durable entities and a durable functions implementation. So you can have a look at what the different in the programmatic models between the two are. And then that first demo that we saw there around how we could create a basic workflow is in my GitHub there. I've got both C# and .NET in there, C# and F# in there, depending on what kind of .NET flavor you want to work with. I also have a JavaScript implementation as well, so you can see if you're a Node.js developer or a JavaScript developer, how you can use Azure Functions with durable functions to do a workflow using that side of the framework.
Fantastic. Thank you so much for your time today.
Thanks for having me.
You've been listening to Aaron Powell talking about durable entities and durable functions. Thanks for watching.